This is Siva. 15 plus years of professional consulting experience in designing, developing, administering, and implementing of data integration and ETL and data warehouse and big data applications, and also building the big data applications in cloud like GCP and Azure. I've had 7+ years of Azure experience. Um, this program today, I would like to walk you through an Azure data engineer with a Snowflake. So this program is designed to train people work with Azure data products and build the ETL applications along with the Snowflake. And this program is designed not only to crack the interviews, but also to withstand with daily challenges the data engineers that they encounter. Okay, with that in mind, so I would like to walk you through a simple demo, and I'm going to show you the roadmap to Azure Data Engineering Platform and also Snowflake tool set. So the topics I'm going to cover as part of this demo are a little introduction and the types of data we got and what the methods that we use to process that data and different types of analytics and an introduction to cloud computing and the cloud computing service models that we got right now and a data engineering life cycle, and finally Azure data engineering products, and also we'll cover a Snowflake toolkit. Okay, and now let's take a look into the first generation ETL pipelines. So way back in 2000, so most of the applications, they deal with a structured data. All the applications, they generate a structured data, and with that structured data, the ETL product extracts that structured data and then builds a warehouse. On top of that warehouse, BI and reports are built. So this is pretty much a straightforward. But nowadays, from last couple of years, the AI and machine learning importance is growing on. As you can see now, the ETL and then the warehousing architecture is a little bit different to the first generation architecture. As you can see that along with the data warehouse and BI reports, we also got a data science and machine learning elements. So now, as you can see this one, the data science and machine learning, the importance of AI and machine learning in conjunction with data is significant and continuously growing across various industries, because AI and machine learning, they provide enormous benefits. To name a few of them, they provide data-driven decision making, automation, personalization, predictive analytics, and healthcare improvements. These are just quite a few. So AI and machine learning, they leverage the large volumes of data sets to analyze trends, insights, patterns, which are very challenging for humans to uncover. So machine learning and AI elements, they not only consume the structured data, but also they consume semi-structured and unstructured data. So I've been talking a lot about a structured data and semi-structured data, unstructured data. These are all types of data, which I'm going to walk you through in the next slide. As you can see this one in this diagram, so there should be a place where we need to store all the structure, all kinds of a data. That's where a data lake comes into a picture. So data lake is a dumping area where it can store and save all kinds of a data. Once data is stored in the data lake, it can be redirected to different departments and groups. So structured data can be directed to a ETL product, and that ETL product can consume that structured data and loads into a warehouse. And structured, semi-structured and unstructured data, they can be directed to a data and machine learning department. So data lake is a unified storage location for all kinds of a data. So these are all current trending data architectures, so in cloud. So we're gonna walk you through and show each and every element. We introspect each and everything. And now let's look into this one. We've been talking a lot about structured, semi-structured, and unstructured data. So basically we'll segregate and dissect each and every data type. So structured data, basically with a few examples, I would like to show you this one. So structured data, what is a structured data? A structured data is like, when it has two properties, then we call it as a structured data. So when the data is properly organized and formatted, and also it possesses a strict schema, then we call it as a structured data. So for example, a database table, if you see this database table, by looking at this table, the data is nicely organized and formatted into table, into rows and columns, right? So it is organized, and also it has a strict schema. What is a strict schema? So schema means, it should identify every column with its data type. So as you can see in this example, employee ID, name, and city, they have a data types. So Oracle table, or in fact any relational table, will be classified as a structured data, and spreadsheets, they are also classified as a structured data because they are organized, and also they got a strict schema. Now let's look into a semi-structured one. So semi-structured one, they're organized and formatted, but they don't have they don't have a strict schema. They can have some kind of a schema, but it's not, they may or they may not have schema. Let's take for example, JSON file. In the JSON file, as you can see this one, when I take a look into the JSON file, you can easily see that now a key value pairs. So we can identify name, age, and city. These are the columns and their associated values, or here as well. So, but this JSON file is not giving an information about the data types of those keys. So I can't find out what would be the name, what would be the data type of that name key. So I can assume anything. It could be a string, or it could be a varchar, it could be anything. So similarly, age, I can presume it could be a string, or it could be it could be an integer, it could be a big int, or whatever. I can presume anything, right? So it is not enforcing a strict schema. So that's why JSON, we call it JSON as a semi-structured data. And on the other hand, there is unstructured data. So with unstructured data, neither the data is organized nor they have any schema. So basically, it's very complex. It's not easy to process with any type of a programming language like a SQL or a Python or anything. They need an additional support. like a machine learning tools to process these unstructured files. So to name a few of the unstructured files, PDFs, text files, any media files like audio and video, these are all part of the unstructured data. So, and as you can see this one, when the data is structured, it's very easy to access, analyze, and build the reports. So the basic toolkit we use for the structured data is a SQL, right? With a SQL, you can do all kinds of pre-processing, building you, your ETL applications and all. So with a semi-structured and all, it's not that easy for a SQL to translate it and pre-process JSON file, but it requires some kind of a additional support for a SQL. Uh, and with the unstructured data, as I mentioned before, so SQL and any other programming language, they can't do that. They need an additional libraries like a machine learning things to process this unstructured data. So that's about different types of data. Now let's look into the different types of processing. So now we understood the types of the data. Now let's dive into a different type. How do we process that data? So there are three types of processing: batch processing, near real-time processing, and real-time processing. So what is a batch processing? So batch processing is about, it always happens on a bounded data that has been collected over a period of time. A classic example is employee payroll system. Employee submits their timesheets for a month, for a 30 days, and at the end of the month there would be an ETL pipeline that process the timesheets that he submitted for last 30 days, and then it generates the payments, right? So another example is energy and utility bills. So similarly, over a period of time, let's say bi-weekly or a monthly, the data will be collected, and then the ETL process will be done, and then generate the reports at the end of the month. So as you can see that there is a lag between the occurrences of the data and also the processing of the data. Here in an employee payroll system, the delay is 30 days, right? So that's the batch processing. And on the other hand, there is near real-time processing, which is it, it is the near real-time processing refers to systems and applications uh, which minimizes the delay between the occurrences of the data and also the processing time. Let's say, for example, let's take when we order something in a online e-commerce application, when you place an order, it authorizes your payment, and then it confirms the order. That will be done in 1 or 2 minutes time. And another example is um, when you go to a bank and then you apply for a loan, and that application should give a response in 1 or 2 minutes, right? So here the difference between the processing time and then the data generated time is 1 or 2 minutes, or sometimes it's seconds, less than a minute. So that is minimizing the delay and giving some degree of instance response. So, and there is another thing that is a real-time processing, which should respond uh, instantly, immediately. Sometimes it goes to a milliseconds. For example, a stock market, and that should always gives you a milliseconds response. And also live streaming is another example. It's also a milliseconds delay. More than that, it can't be acceptable. So in an ideal data engineering world, most of the data engineering guys and most of their time they spend they spend on building the batch processing. And let's say I would classify that as a 90% on a 90 to 95% they spend on the batch processing, and remaining 5% on near real-time processing. So real-time processing is very rare. So our focus is mainly on a batch processing and near real-time processing. Uh, yeah, with that, let's get into types of the analytics. So now we understood different types of a data and different methods of processing that data. And now let's see what are the different types of analytics that we got. There are a few types of analytics, starting with the descriptive analytics. Basically, it summarizes, what happened in the past. Let's say, for example, like, for an e-commerce application, getting the sales for over the last few months. So this can be done by having a simple data warehouse, and then on top of that data warehouse, a few reports. With those few BI and visualization reports, I can go back. I can get what happened in the last 1 year time. I can get every month sales for a given product, right? So this is all about, what happened in the past. Collect the history and then build the reports on that history. That gives the information. And quite extension to that descriptive analytics, there is diagnostic analytics. So along with what happened, we would like to understand why it happened. So that's called a diagnostic analytics. So this can be done by using some statistics and data mining. So to give a best example for this, for a given product, the sales were too high in the last quarter compared to the compared to this quarter. Why? That root cause can be found by using the diagnostic analytics. And the next one is a predictive analytics. This is actually, based on the history and the current data. It's forecasting the future, what's going to happen in the future. So based on the current sales, it estimates the demand for the given product in the next quarter. So that's a predictive analytics. So this will be done by using some statistic algorithms plus a machine learning. And little extent, way beyond the predictive analytics, there is a prescriptive analytics, which is not just only forecasting the future, but also giving some recommendations and suggestions for a better outcome. So taking the same example, predicting what's going to happen for a given product in the next quarter, and also deciding what would be the estimated price, what would be the best price for that product in the next quarter. So that kind of a recommendation also be part of this prescriptive analytics. Yeah, the prescriptive analytics will be done by using AI and machine learning algorithms. So with that in mind, we got the basics of the data and the methods of processing and the types of analytics. Now it's a time to focus on the cloud computing. Why now everywhere everyone is shifting into a cloud? So, but why? What are the benefits of migrating your data or building your data platforms and cloud? So let's say a simple example from my experience. I would like to share this experience with you. So before cloud and all, few years back, we have a Hadoop cluster. Hadoop cluster where it got 100 servers. So now to maintain and manage these 100 servers and administer these Hadoop clusters, we got 30 people just to manage them, manage those Hadoop clusters and making sure that they're always up and running. So we got 30 people. So now, as you can see, this one, though Hadoop clusters are commodity servers, they don't, you can, they're bit cost effective, but maintaining and managing those Hadoop clusters, I need human resources, right? And now, as you can see, this one managing and employing these 30 people, and then all up, it's a quite expensive thing. What if, just what if I can eliminate maintaining these servers and managing the infrastructure? Then that's going to save a lot of money for an organization, right? Rather than focusing time on building your infrastructure and managing that infrastructure and eliminating that by we are I can focus only on building my actual data application. So now with the introduction of cloud, with the introduction of cloud, we are offloading these activities, managing, maintenance, all those activities are offloaded to cloud service providers. The users are solely focused on their application and building their data platform. Okay, so that's the use of the cloud computing and why the organizations are so much interested in migrating their data analytics applications to cloud. In an on-premise world, it's very tedious and also expensive. Now, now, what is a cloud actual definition of a cloud service provider? Cloud service providers offer a range of services and resources delivered over the internet. A few examples like AWS, Azure, and Google Cloud, Oracle Cloud, Alibaba. These are all renowned cloud service providers right now. So, what are the basic characteristics for any given cloud service provider? No, they should provide on-demand self-service. That means anybody in the world with just a few mouse clicks, they can uh, get what they can get the resources and the servers, whatever they want from that cloud, right? And also it should provide a scaling and also it has a global reach. Anybody, your application must be available to anyone in the world, right? And it should provide reliability and high availability. That means your application, we expect that it should be 24/7 available, and also a certain security measures should be in place. So data is very important. So security measures on your data, those things must be there. And yeah, I mean, as you can see this one, you so many complex activities that were there in an on-premise world were offloaded to cloud service providers. So they are doing lot many things on their background. So the users and the organizations, they just need to focus on building their application and data, not bothered about any infrastructure maintenance, management, and administering of that infrastructure. So all the cloud services, cloud service providers, basically they offer different types of products, and we characterize them. Uh, Basically, let's compare them with the on-premise model. So now on the on-premise model, as you can see that from the bottom, starting with networking, storage, servers, virtualization, and OS, middleware. So everything from the basic infrastructure to middleware OS system, and also your application and then the data. Users should be responsible for everything. So user or organization always uh, assess their infrastructure, buy that infrastructure, and then maintain that infrastructure, and also apply the appropriate OS patches on that application on those servers, and also on top of that, they build their application. So that includes so many complex tasks. And now, when we get into a basic model on the cloud service, we call it as infrastructure as a service. In that model, as you can see, these orange things, starting from network to virtualization, those things will be offloaded to cloud service provider. So here in the IA infrastructure as a service model, basically user will be provided with a virtual server with an inbuilt networking and then storage. So that bit will be provided to user. So user is responsible to install OS, appropriate OS and the middlewares on those virtual machines. And then finally, they're going to build their applications and then the data in that virtual server. So as you can see this one, this model is really useful when the user or organization wants to have a greater control on their infrastructure. Let's say, I need 10 servers, 10 virtual machines for my application. So that kind of a control, user wants that control in his hand, then infrastructure as a service model, that is an appropriate model for that use case. On the other hand, now let's get on to the past model. So platform as a service model. So as you can see this one, so the orange task, almost all the orange tasks are offloaded to cloud. So basic infrastructure plus the middle level OS, virtualization, middleware, runtime or runtime containers, everything will be done by cloud service provider. So the user is only responsible for building their application and then data. The best example for this one in our Azure is, your Azure Data Factory. So you have that product, but you just straight away get into your Azure cloud and start using that product. With that product, you define your ETL and the data engineering data pipelines, and then that's it, right? So you're not bothered about the underlying servers for that ADF service, or maintaining and managing that ADF service. So everything will be done by Azure. So all we do is we create pipelines. That's it. So that's a classic example relating to a pass in Azure, Azure Data Toolkit. And the other one, and the final thing is a SaaS model. So software as a service, as you can see now, everything, everything offloaded to Azure service provider. So starting from the infrastructure, middleware applications, and then the actual application uh, is also done by the customer. You're just using that service as a product, right? The classic example is a Gmail. No, you're simply using your Gmail, right? You're not doing anything, right? You're not building anything for that. So that's an example of SaaS. Now, now we've seen the benefits of a cloud computing, and also a little bit about the different types of service models offered by a cloud service provider. Now, let's get into the ETL and the data pipeline stuff, the actual data engineering stuff now. So in the olden days, we got the ETL pipelines. When I say ETL, is typically meant for the data warehousing and building the data warehousing, and then the business intelligence applications. So it's predominantly focused on building the ETL pipelines for a batch processing. So uh, whereas on the other hand, new age data pipelines, it's not just limited to batch processing, or not only loading the data into a data warehouse or a business intelligence applications. It could be way beyond that, for transferring the data from and making sure it available for the data science and machine learning fellows, moving the data from data lake to data warehouse, and also dealing with the real time or a streaming data. So these are all part of the data pipeline. So any data pipeline is way bigger than the ETL. So it handles different types of batch processing and different types of thing, and also, yeah, lot many things. And now let's look into a data engineering life cycle. So what a what's the what a data engineer perform as part of his daily active daily roles, as part of his role. So basically, data engineer, he focuses on building the ETL pipelines, building the data pipelines, right? So when I say data pipeline or ETL pipeline, that includes few steps, right? One is getting the data from the source systems, and then transforming the data, and then serving the data, right? So as you can see over here, so from generation to ingestion, that's a data integration. So it connects to different source systems, extracts the data, ingests the data into a data lake, in the storage. As you can see, this one storage, that's the data lake. From that data lake, uh, that he does transformation, pre-processing, deduplications. There are a lot many things in transformation, pre-processing, deduplications, according to the business logic. You might add columns, delete columns, create new logic, right? So all kinds of ETL transformations. And finally, loading the data into a destination. That destination could be the data warehouse or any other data platform, right? So once the data is loaded to a destination, that will be consumed by machine learning and then the analytics guys. So Yeah, I mean, as you can see, this one data engineer is responsible for building a data pipelines, extracting the data from different data sources, transforming the data, and making sure that it is loaded into a destination, which will be consumed by the other guys, the downstream applications. And also, along with this is a basic and a core task that should be performed by a data engineer. Along with that, a data engineer should also take care of the security and then the data access controls, data governance, and orchestrating the pipelines, orchestrating these data pipelines. So these elements also are, data engineer should keep in mind, and then he should build and incorporate these elements in his data when he's building the data pipelines. So yeah, now since we have seen the different aspects of the data engineering life cycle, and let's see what are the toolkit data products that are available in Azure data engineering data toolkit. So yeah, as you can see now, on the screen, Azure Data Directory, that's where the actual users and groups are configured in the Azure Data Directory. And Azure VM is just a virtual server. And for any application processing, we use Azure VMs. Azure Data Lake, it's a proper data lake, so where we dump all kinds of a data, structured and semi-structured, unstructured, everything can be stored in a Azure data lake and unified storage location, basically. So from there, we use an ETL product, that's Azure Data Factory, to build the ETL pipelines, data pipelines, to extract the data from data lake or from a SQL database, or it got a wide variety of connectors, uh, 80 plus connectors to connect and then extract the data from on-premise as well as the cloud applications. So we mainly focus, as part of this course, we focus on mainly on the Azure Data Factory and Azure Databricks. So this is right now, it has a huge demand right now. I see uh, there is a huge gap in demand and supply, actual supply. So there is a lack of data engineers with Azure Databricks experience. So yeah, we will focus mainly on Azure Data Factory and Azure Databricks as part of this course, making sure that you got the required information to crack the interviews. And I'll cover most of the scenarios that you could expect in an interview. And also from my real-time experience, I can share those things, starting from different types of file formats. Why are we using those file formats? All these kinds of uh, uh, important interview questions, as and when we are into that product and that topic, I will cover those bits. And also finally, we got the Azure Synapse. It's like a data warehousing product on Azure. We'll look into that Azure Synapses as well. And yeah, and also we'll see Azure SQL database, and a few, and also we'll cover basics of the SQL, and basics of the data warehousing concepts, all the things when going along with this course. And finally, we'll see the Snowflake thing. So in Snowflake, uh, we'll starting with the ingestion, we'll see working with the different types of data, with a structured, semi-structured data, and loading those structured, semi-structured data into Snowflake by using copy and then the Snowpipe utility. And also we'll look into that dashboards and web UI interfaces available in Snowflake. And on the transformation section, we see how we can do the transformations using SQL statements, and also see stored procedures, how we can write some stored procedures, and also um, implementing your Spark pipelines using a Snowpark in a Snowflake world. And also at the end, finally we'll see data lake export, data lakes exports, and then the data sharing concepts in the Snowflake one. So with that, I think that gives enough and sufficient information for a data engineer to know and a Snowflake and work with a Snowflake without any fear. So with that, I'll conclude this demo, and I would like to walk you through on the program that we are going to cover. So this is a fast track 5 weekends program. Saturday and Sunday we'll cover this program, and it's a Saturday and Sunday 10 a.m. to 1 p.m. And if you have any questions or anything, and contact on this email or this phone number. And so what we're going to cover on a weekly basis is the week one. Um, we'll introduce you to cloud intro, and then the Azure cloud fundamentals like resource groups, ADLS, data lakes, and on Azure SQL. We'll introduce you to Azure SQL database as well with a few SQL commands. We'll cover uh, basics of the SQL. You know, if you already knew SQL, it's well and good. If you don't know, that's okay. We're gonna cover a bit the basics of SQL that that's are which are mandatory for a data engineer. So we are going to cover those bits as well, and a few practice things on Azure SQLs. And also we'll introduce you to ADF in the first week itself with the basic things. And then in the week two, we are aiming to cover in detailed ADF with real-time pipelines. So I think this in this section, I'm going to cover a few of the interview scenarios. Most of the ADF interviews will be like, they give you some kind of a scenario, and then they will assess your thought process on how you are building the ETL pipeline. So those kind of a scenarios, I would like to cover on that Azure detailed ADF detailed session. And followed by that, we'll introduce you to basics of Python and Spark core. So those are very important to do your things on your data bricks. So that's a week two. Week two is all about, in detailed ADF plus Python and then the Spark core. Week three, Spark SQL, and then the Azure data bricks. So that's where we spent. So again, Azure data bricks and Spark, that's also a huge topic. That's includes different types of file formats, performance tuning, various scenarios. We are going to cover everything on that in week three related to Spark and Databricks. And week four, data warehousing on Azure. We use Azure Synapses, and also we'll introduce you to logic apps. The logic apps is right now, whenever you see any Azure data jobs pack, so predominantly everybody is looking at logic apps. So we'll cover that logic apps up to a level, a certain level, so that uh, you can go to interviews without any worry. And also we'll introduce you to a Snowflake in week 4, the basics of Snowflake, and we'll try to cover the ingestion module in that week 4. And in the week 5, the in depth of the Snowflake, and then the interview preparations. And along with that, every week, 1 hour, I'll spend 1 hour. Let's say a Wednesday or a Thursday, I'll be available for 1 hour, uh, so that if you have any questions or anything, I can answer those things. So I'll try to give you some kind of scenarios at the end of every week. uh, I'll try to give some scenarios for you to practice at your home and learn, and then assess yourself. And also will help you on a resume reviews, and with a few sample data sets and references for the documents, where to read and what to read, and reference documents and useful links, further. And also, yeah, as I mentioned many times so far, will cover you the most of the interview scenarios, and interview preparation tips, and yeah. And also, most importantly, and will help you on setting up your cloud account lab, and also how to practice the things. So yeah, uh, we'll cover as much as we can that can help you to practice on Azure without any issues. So yeah, that's it. Thank you for everything. Thank you for listening to this. And if you have any questions, anything, please contact on this email and this on this phone number. Thank you.